Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know for our upcoming test. So the test is divided into two sections. Firstly, number, secondly, algebra. So we'll go through these topics in number. Note directed numbers means operations involving negative numbers. And then we'll go through all the algebra that you need to know. So note there will be no calculators in this test, so make sure you can do all of the calculations that I'm about to do by hand. So let's get into it, starting with directed numbers. So we'll start with multiplying and dividing directed numbers. So all you do is just multiply or divide the numbers as normal, and then use these rules in black to determine whether or not your answer should be positive. So if I had something like, say, 8 times negative 3, all you do is go 8 times 3 and decide whether your answer should be positive or negative. So here we have a positive times a negative. If both numbers have a different sign, the answer is negative. So this will be an answer of negative 24. So note, squaring is just multiplying by itself. So if you have something like minus 7 squared, that is just minus 7 times itself. So if you have a negative times a negative, both numbers have the same sign, the answer is positive. So 7 times 7 is 49, answer positive because it's a negative times a negative. So whenever you square a number, you should get 0 or a positive number. You never get a negative answer when you're squaring. So it works similarly for division. Let's say I had 81 divided by negative 9. So you just go 81 divided by 9 is 9 and determine whether your answer should be positive or negative. So because the numbers have a different sign, the answer is negative, and we're done. So this rule does not necessarily apply for adding and subtracting. So let's say I had something like minus 4 plus negative 3. So the rule up here doesn't apply for adding. I can't say because it's a negative plus a negative, the answer is positive. In fact, the answer will be negative. Instead, I use these rules. So here I'm adding a negative. So to add a negative, I subtract its opposite. So to add negative 3, that's the same as subtracting 3. The opposite of negative 3 is positive 3. So it's minus 4 subtract positive 3. So if you're stuck with adding and subtracting, which can be difficult, you can draw a number line. So remember, for minus 4 minus 3, I'd start at minus 4. Then I'd go 1 to the left, which is minus 5. 2 to the left is minus 6, and 3 to the left is minus 7. When you're subtracting a positive, you go to the left. So minus 4 minus 3 is equal to minus 7. So if I had something like 32 minus, let's say, negative 24, so what I'm doing now is I am subtracting a negative, so I need to add its opposite. So this will be 32. The opposite of negative 24 is positive 24, and I add its opposite. So the answer would be 56. All right, let's now look at operations with fractions. So we'll start with multiplying and dividing fractions because that's easier than adding or subtracting. So it turns out to multiply two fractions, we just multiply the top numbers and multiply the bottom numbers. So let's say we had something like 3 over 8 times 4 over 15. So we just multiply the tops and multiply the bottoms. Now, when you're multiplying, you need to check that your answer's simplified. So this fraction here is not simplified because 12 and 120, numerator and denominator, have a common factor. So simplifying a fraction means we don't change its value, we just write it with smaller whole numbers. So to simplify this fraction, what we can do is divide the top and the bottom by the highest common factor, the highest number that goes into 12 as well as 120. So the highest number that goes into 12 and 120 is 12. So I can divide the top by 12 and the bottom by 12. So 12 divided by 12 is just 1. 120 divided by 12 is 10. This fraction here and this fraction here have the same value, both equal to 0.1. This one's just simpler because it has lower numbers in it. So remember that squared means to times by itself. So something like 2 over 5 squared means we just times the fraction by itself. Once again, we times the two top numbers together and the two bottom numbers together. This fraction here is simplified because 4 and 25 have no factors. Another point to note is that of means times. So let's say I have 2/3 of 42. So that is the same as 2/3 times 42, because of means times. When you're multiplying by a whole number, write it over 1. 42 and 42 over 1 are the same thing. So now what we can do is exactly what we've done before. We can just multiply together the two top numbers, multiply together the two bottom numbers. Now we see, can our fraction be simplified? Well, it can, because 3 goes into 84. This just says 84 divided by 3, which is 28. 2/3 of 42 is equal to 28. So let's look at division now. So when you're dividing, you flip the second fraction and make it a times. So let's say I have a half divided by 2/3. So what I do, I keep the first fraction the same, flip the second fraction, and make it a times. So now I just do exactly what I've done before. 3 times 1 is 3, 2 times 2 is 4. And I'm done. This fraction can't be simplified. So the reason for this is division and multiplication are essentially the same thing. Dividing by 2 is the same as timesing by a half. You know that. You know that a half of 40 is the same as 40 divided by 2. So that's why this works. So if you're multiplying or dividing and it involves mixed numbers, first change them to improper fractions. So if I want to do something like this, I change first to improper fractions. So the way you make improper fractions is you take the whole number part, you times by the denominator and add the numerator. So I go 1 times 5 is 5 plus 3 is 8. That's the new numerator. I keep the same denominator. So 1 3/5 is the same as 8 over 5. So similarly, for 2 1/4, I go 2 times 4 plus 1 is 9. And I keep the same denominator. So now I've got 8 over 5, which is 1 3/5, divided by 2 1/4. So I'm going to do exactly what I did before. I'm going to keep the first fraction the same, flip the second fraction, and make it a times. Now I just times the two top numbers and times the two bottom numbers, and I'm done. So now let's look at adding and subtracting fractions. So adding and subtracting fractions is a little more difficult because the denominators have to be the same. Now, if we have something like 3 over 7 plus 2 over 7, well, that's easy because the two bottom numbers, the denominators are the same. Then we just add the two top numbers and leave the denominator the same. That's easy. But what if I had, for example, 2 over 5 plus 3 over 8? So I can't just add the top numbers and add the bottom numbers. That is not how fractions work. What I need to do is first make these have the same denominator. So I need to times this by some number, times this by some number, so they have the same denominator. So the lowest number divisible by 5 and 8 is 40. What I'm saying is if I times 8 here, the denominator of this fraction will be 40. And if I times this denominator by 5, it will also be 40. And I will have the same denominator, and then I can add them. So if I times the bottom by 8, I must times the top by 8. What you do to the bottom, you must do to the top. What you do to the bottom, you must do to the top. So 2 over 5, what I'm going to do now is change that. So I go 2 times 8, 5 times 8. That's the first fraction. The second one is 3 times 5, and then 8 times 5. So this and this are equivalent. This fraction and this fraction are equivalent. It's just now they have the same denominators. I can add them. So I just add the numerators and leave the denominators unchanged. So if I wanted to do a subtraction, it'd be very similar. I would just subtract the numerators. So 3/4 minus 1/6. You can see again, denominators are different, so I have to make them the same. The lowest number divisible by 4 and 6 is 12. So I can times this by 3. That will make this denominator 12. I can times this by 2. That will make the denominator 12. What I do to the bottom, I must also do to the top. So 3/4 is the same as 9/12. 1/6 is the same as 2/12. This time I'm subtracting. So I just go 9 minus 2 is 7 and keep the same denominator. So now let's look at an example involving mixed numbers. So let's say I have 3 and 5/6 plus 4 and 3/10. So what I could do is what I did in the previous slide with multiplying and dividing. I could make these two improper fractions. But what else I can do is I can add together the two whole numbers. 3 plus 4 is 7. And then I can add the two fractions together because I know how to do that very easily. 5/6 plus 3/10 is just like all the questions I did here. So the lowest common denominator is 30. I'm going to times top and bottom by 5, top and bottom by 3, so the denominators are 30. So I leave the 7 alone. 5/6 is 25/30. 3/10 is 9/30. So what I get now is 7 and 34/30. So this is what we call an improper fraction. It is more than 1. So to change an improper fraction to a mixed number, you just do this. So I'll leave the 7 alone. What we're saying here is 34 divide 30. How many times does 30 go into 34? It goes once, remainder 4, and I keep the same denominator. So this will just be 8 and 4/30. 4/30 is 2/15. Okay, so I could have made these improper fractions and then added them. Nothing wrong with that. I just thought it would be easier if I do the whole number parts separately this time. All right, now let's do some worded problems involving fractions. So we will do both of these worded questions. Let's start with the black one. James, Oliver, and Harry share a pizza. James eats 2/5 of it. Harry eats 2/9 of it. What fraction is left for Oliver? So here what we have is like one whole pizza because fractions are parts of a whole. James ate 2/5, so we'll take away the fraction he ate, and then we'll take away the 2/9 that Harry ate. That's what will be left for Oliver. So to perform this calculation, we need to have fractions with the same denominator. So I need to times top and bottom by 9, top and bottom here by 5, so they have the same denominator of 45. But I can also change 1 into a fraction. 1 is 45/45. 1 whole is 45/45. So then 2/5 is 18/45. 2/9 is 10/45. So now that all fractions have the same denominator, this is easier. Just go 45 minus 18 minus 10, and I'm left with 17. Keep the same denominator. So 17/45 of the pizza is left. So let's look at the question in blue, which is much harder. So it says in a class of students, 3/5 of those with blue eyes also have blonde hair. If 12/25, 12/25 of the students have both blue eyes and blonde hair, what fraction of the students have blue eyes? So this is a really hard one. So what we're saying here is this. We've got looking for the number of students with blue eyes. So I'll leave that in a box. So 3/5 of these students here with blue eyes, that comes to 12/25, 12/25 of the class. We need to know what fraction we can put here in the box. It doesn't actually matter how many people have blue eyes or blonde hair. Just like here, it didn't matter how big the pizza was, how many slices, we can still figure it out. So remember, of means times. So I can rub that out and write a times. So I'm saying, what do I times by 3/5? 3/5 of what gives 12/25? So remember, we can undo timesing by dividing. What goes in the box will just be 12/25 divided by 3/5. We undo timesing by 3/5 by dividing by 3/5. So remember, to do that, what we do is we flip the second fraction and make it a times. Now, to make it easier on ourselves, rather than doing 25 times 3 involving big numbers, we can cancel. 5 goes into itself once, goes into 25 5 times. 3 goes into itself once, and it goes into 12 4 times. We can do that. We can cancel anything on the top with anything on the bottom as long as we're timesing. So what I'm left with is 4 times 1 and over 5 times 1. That's just 4 over 5. So that means 4 over 5 goes in the box. 4/5 of students have blue eyes. Because of these 4/5, 3/5 of them gives 12 over 25. All right, let's now quickly look at decimals. So if I want to add or subtract decimals, I just line them up and use long addition or subtraction. So what I mean by that, if you have something like 0.07 plus 1.296, you just line them up. 0.07, 1.296. Now, because there's an extra number here, I can add a 0 here and it won't change it. So we're adding. So you know how to do this. We'll just use long addition. So we go 0 plus 6 gives us 6. 7 plus 9 is 16. So we write a 6 and carry the 1. So now we have 1 plus 2 gives us 3. And then 0 plus 1 is 1. So the answer is 1.366. And we're done. So let's do this one. 1.01 minus 0.09 we'll do using long subtraction. So I want to start off by going 1 minus 9, but that would give me a negative. So what I want to do is borrow. I want to borrow 1 from here. Problem is there's nothing there. So what I need to do is borrow, for this one, I need to borrow from here. So I'm going to cross this out and make it a 0. So then what I'm going to do is make this one a 10. So I'm borrowing the 1 and moving it over here to make this 10. So now there's 10 here. I can borrow 1 from here to do this here. So I can't do 1 minus 9. But what I can do is make this 11 minus 9 if I borrow 1 from the previous. So I go 11 minus 9 gives me 2. Now I've got 9 minus 0 is 9. Now make sure decimal point under decimal point, and then I've got 0 minus 0, which is 0. The answer is 0.92. Now let's look at multiplying decimals. So when we're multiplying decimals, we just multiply the numbers as if there were no decimal point, and then figure out how many numbers there should be after a decimal point. So let's say, for example, I was doing 0.4 times 1.2. So what I do is I just forget about the decimal points, and I do 4 times 12, which gives me 48. Now, in the question, there was 2 numbers after the decimal point. So my answer needs to have 2 digits after the decimal point. So I put the decimal point there. It will be 0.48. So 0.4 times 1.2 gives me 0.48. So let's say I have 0.06 times 0.24. So what I do is I multiply the numbers without the decimal point. So I go 6 times 24. So that actually gives me 144. So the number of points after the decimal point, 1, 2, 3, 4. I only have 3 digits. So what I need to do is add in a 0 at the start and then put the decimal point in. So it doesn't matter whether I write it as 0.0144 or 0.0144. Same answer. So my answer has 4 digits after the decimal point because there are 1, 2, 3, 4 numbers after the decimal point in the question. All right, how easy is that? Now the last part of number we'll go through is BIDMAS. So BIDMAS lets us know the order in which we perform operations. We do anything in the brackets first, followed by indices, which means powers. We do powers second. Now division and multiplication, because as I said before, they're sort of the same thing. They're sort of the same rank, same with addition and subtraction. So for division and multiplication, you don't always do division first. You do whichever occurs first from left to right. Similarly, for addition and subtraction, whichever occurs first from left to right. but you always do these before these. So let's look at some examples. So let's say minus 7 plus 3 times negative 4. So we have an addition and a multiplication. Multiplication is above addition. Multiplication is done first. So when I'm showing my working out, I leave the minus 7 alone. I do the 3 times negative 4 first. So 3 times negative 4 is actually negative 12. So now I just go minus 7 minus 12, and then I'm done. So let's say I want to evaluate this, say what it is equal to. So what I'm going to do is everything in the brackets first, because brackets is first. So what I do is I go minus 4, leaving that alone. I'm going to do the multiplication in the brackets first, because multiplication comes before subtraction. So minus 3 times minus 2 is positive 6. So I've got minus 4 plus 6 squared. Now, because the addition's in the brackets, I'm going to do it first. So I'm going to go minus 4 plus 6 is positive 2. And then 2 squared is 4. And then we're done. So now we're just going to look at inserting brackets into a statement. So let's look at these two statements. They're both untrue. Firstly, this one, minus 8 plus 3 times 2 doesn't equal minus 10. Because what we would normally have to do is 3 times 2 is 6, minus 8 plus 6 doesn't equal minus 10. But if we insert brackets in this statement, it will be true. So brackets, all they do is change the order of operations, because sometimes we want to add first, and then get our answer, and then times. So what brackets can do, if I put them around here, they will now enable us to do the addition first. So now I get minus 5 times 2 equals minus 10. And this is a true statement. So let's look at putting brackets in here to make it a true statement. So where could we put brackets that would make this actually change the order of operations? Because normally what I'd do is I'd go minus 20 plus 2 divided by minus 9. I'd do this first, then this second, then add together my two answers. So I could put brackets, say, here to change the order of operations. But minus 4 times 7 is minus 28. Divided by minus 9 doesn't give me 2. So that's not where I want to put the brackets. Instead, I could put the brackets here. I could do everything first and then divide my answer. So minus 4 times 5 is negative 20, plus 2 is negative 18. Negative 18 divided by negative 9 is 2. Now this is a true statement. It wasn't a true statement before I put the brackets in, but the brackets enable me to change the order of operations. I do the whole thing and divide it, rather than doing multiplication, then division, then adding. All right, let's now go on to algebra. So the first thing we're going to look at in algebra is operations with terms, adding, subtracting, multiplying, and dividing terms. So terms are just sequences of pronumerals, which means letters, and numbers. So something like 4a is a term, 4 is a term, say 3b is a term. All of these are terms. Now, they are not like terms because they don't have the same letters. Like terms need to have the same letters. We could not add or subtract these three terms. We could multiply them, however. So if I wanted to multiply 4a by 4 by 3, I just operate on coefficients. So coefficients means number in front of. So I would just go 4 times 4 times 3. I just do the numbers separately. So 4 times 4 times 3 is 48. And then I would write the two letters like that. If I had, say, 3c times minus 2d, I'd go 3 times minus 2 is negative 6, and then just write the letters. If I have something like 5x times 2x, I go 5 times 2 is 10. X times x is actually x squared. Because remember, this squared means times by itself. It means x times x. So dividing terms is pretty similar. If I have something like 12x divided by 4, I just go 12 divided by x by 4, is 3. and leave the x. It can become more complicated when we're simplifying. So if I have something like 15a over 20, so this is the same as 15a divide 20, I simplify the fraction. So 15 over 20, you have to divide by a common factor of 5. 15 divided 5, 20 divided by 5, and I leave my a there. If there's a letter on the top and the bottom of the fraction, you cross it out. So 15a over 20a, because the same letter is on the top and the bottom of the fraction, I cross it out, cancel it out. So this will just be 3 over 4. This time the answer doesn't have any a's. So let's add something like 12xyz over 20xz. So I go 12 over 20 is 3 over 5. X divided by x, they cancel out. Z divided by z, they cancel out. And I'm just left with a y on top. For something like 10ab over 12abc, same thing. 10 over 12 simplifies to 5 over 6. Cross out the a's, cross out the b's. This time the c is on the bottom, so I write it as 5 over 6c. So that's multiplying and dividing terms. Let's look at adding and subtracting terms. So when adding or subtracting, once again, we operate on the coefficients. So if I have something like 7x plus 2x, if you had 7x's and you add 2x's, you have 9x's. If it was 7x minus 2x, I just go 7 minus 2. They are the coefficients. 7 minus 2 is 5. And write the x, okay? So note, unlike dividing, when we go x minus x, we don't cross the x's out. That's only in dividing. So this becomes a bit more complicated because you can only add or subtract terms that are like terms. So let's say I have something like 4y plus 5 plus 2y. So here we have 1, 2, 3 terms. 4y and 2y are like terms because they both have a y. So we can add them. 4y plus 2y is 6y, and then we leave the 5 alone. I can't add 6y and 5. This term has a y, this doesn't. I cannot add them to make 11y. So remember, I can multiply and divide terms even if they're not like terms, but I can only add or subtract them if they're like terms. So let's have something like 12a minus 3b plus 5a minus 2b. So 12a, that's a term, and then I have plus 5a is a term. So 12a plus 5a, because they're like terms, I can add them. So 12a plus 5a is 17a. So this is not a 3b, this is a minus 3b minus 2b. So I go minus 3 minus 2 is actually minus 5b. So I've done the a's and the b's separately. I can't simplify this any further because this term has an a, this term has a b. They are not like terms. So let's say I had something like 4xy minus 2y minus yx. So I have 3 terms. 1, 2, 3. Now I have to look at which are the like terms. So this one has an x and a y. This one has an x and a y. This one and this one are like terms. It doesn't matter that the pronumerals are written the other way round. That's fine. This and this are like terms. This one and this one. So 4xy minus yx gives you 3xy or 3yx. It's the same thing. Because 4 minus, if it's not written, this is just a 1. So 4 minus 1 gives you 3xy. And then the minus 2y doesn't have any like terms. I leave it as it is. Yes, it has a y, but it doesn't have an x. This one has an x, this one has an x. This one doesn't. So this one is not a like term with either of those. All right, let's now look at putting this into action when we are expanding brackets. So to expand brackets, we start with something that has brackets. We end up with something that doesn't. We use the distributive law. So we distribute the thing out of the brackets to everything in the bracket. So I go A times B is AB, then I distribute the A to the C. A times C is AC, and we have a positive in the middle because there was a positive here. So let's look at some examples involving this. So let's say 4 outside of x minus 3. So no operations written, it's times. I go 4 times x, 4 times negative 3. So for 3 outside of 2x minus 1, I go 3 times 2x. So 3 times 2 is 6, and write the x. 3 times negative 1 gives me minus 3. So this one here is a bit tricky. Minus 4 times 5 minus x. Negatives make it tricky. So it's minus 4 times positive 5 is actually minus 20. Now, minus 4 times minus x, as I said before, if no coefficient, no number in front of a letter, it's just like 1. So this will be minus 4 times minus 1 gives positive 4, and then we write the x. So sometimes we'll have to expand brackets where there's lots of letters. So I go 3a times 2b. So I go 3 times 2 is 6, and then I write the ab. So now I'm going to times 3a by negative 5c. So positive times a negative is a negative. 3 times negative 5 is negative 15. And once again, I add in the letters. So for something like x times x minus 2, I go x times x. X times x is not 2x, it's x squared. Then I go x times negative 2 is just negative 2x. So similarly, if I had something like 4x times 2x minus 3y, I go 4x times 2x. 4 times 2 is 8. X times x is x squared. Then I go 4x times negative 3y. So 4 times negative 3 is negative 12. And then I just write the xy. So sometimes you'll be asked to expand and simplify. So for a question like this, we'll be asked to expand and simplify. So we need to follow order of operations. Remember, this is a times. We do this first. We leave the 12 alone. Then we go 3 times x, 3 times negative 5. Now we simplify by collecting like terms. So we have 12 and negative 15 are like terms. 12 minus 15 is minus 3. And we leave the 3x alone because it has no like terms. And that is the final answer. So this is another question where we'll expand and simplify. We expand the first brackets, expand the second brackets, and collect like terms. So first brackets, we go 4 times 2x, 4 times negative 3. Negative 2. Now, this is a negative 2. Negative 2 times 4 is negative 8. Negative 2 times negative 3 gives us positive 6x. So then we have 8x plus 6x minus 12 minus 8. And we're done. Let's look now at a worded problem involving expanding brackets. So let's say a government agency gives people on welfare $500 a week, but reduces this by 20 cents for each dollar earned over 500. Person earns X dollars and X is more than 500. Write an expression for the amount they receive in terms of X. So this is what they receive. They would receive $500, and we're going to subtract 20 cents for each dollar earned over $500. So this 20 cents for each dollar earned is 20% of what is earned over 500. So 20% is 0.2. You times by 0.2 to find 20%. So now how are we going to write the amount earned over 500? So if they earn $600, they would lose 20% of 100 because they're 100 over 500. If they earned $1,000, they would lose 20% of $500 because 1,000 minus 500 is 500. So if they earned X dollars, they'd lose 20% of X minus 500. Now all we have to do is expand this. So we leave the 500 as it is. So this is minus 0.2 times X. Negative times a positive is a negative, so it'll be minus 0.2x. Then we go minus 0.2 times minus 500. So that will be positive 100, because 20% is 1/5. 1/5 of 500 is 100. Negative times negative is positive. So then we collect like terms. This would be 600 minus 0.2x, and we're done. So what they would get is $600 minus 20% of what they earned, which is a simpler way of saying what these words said there. So that is a very tricky question. Make sure you ask if you don't understand what I said, because we'll now move on to the final thing on the video, which is factorizing. So the last thing we look at is factorizing. So we've just looked at expanding. When I get something with brackets, I end up with something that doesn't have brackets. I use the distributive law to do this. Now what we're going to do, we're going to look at something that has no brackets, and we're going to write it with brackets. We're going to write an expression like this as something times something. That's what factorizing means. Like, to factorize 30, you could write it as 10 times 3. We're writing this as 2 times x plus 3. So going this way is factorizing. So they undo each other. Expanding and factorizing undo each other in exactly the same way that multiplication and division undo each other, or addition and subtraction. You know, if you times a number by 4, then divide by 4, you're back where you started. If you expand an expression, then factorize, you're back to where you started. So to factorize an expression, you just follow these steps here. So let's look at an example. So we'll start off with an easy one. Let's say I have 2x plus 8. So what we do is we find the highest common factor of the two terms. So 2x is a term, 8 is a term. The highest number that goes into 2 and 8 is 2. So we just write it here. Now I say, what do I times by 2, the highest common factor, to get 2x? Well, that's just x. What do I times by 2, highest common factor, to get positive 8? Well, that's just positive 4. If I expand my answer, I would get what I started with. So I've written it as 2 times the bracket, something times something. So I'm done. So let's say I have 3x minus 15. The highest common factor is 3. So what do I times by 3 to get 3x? What do I times by 3 to get negative 15? And that would be negative 5. Another way to think of that, minus 15 divided by 3 is negative 5. So let's look at 6x minus 20. So the highest number that goes into 6 and 20 is 2. So what do I times by 2 to get 6x? I need to times by 3 to get to 6, and then I need to times by x to make it 6x. What do I times by 2 to get negative 20? And that will be negative 10. Once again, if I expand this, I get this. So in each of these cases, the highest common factor was just a number. Sometimes the highest common factor might include pronumerals, might include letters. So let's do 12ab minus 20a. So the highest number that goes into 12 and 20 is 4. But both terms also have an a. So an a is common. It's in both terms. So I'm going to write that out the front. The highest common factor of these two terms is not 4, it's 4a. So now I say, what do I times by 4a to get 12ab? Well, I need to times by 3 to get to 12. And I need the b there as well. What do I times by 4a to get negative 20a? I need to times by negative 5. So let's look at 20cd minus 30de. So the highest number that goes into 20 and 30 is 10. A d is also common to both terms, so it goes out the front. So what do I need to times by 10d to get 20cd? Well, I need to times by 2 to get to 20, and the c to make it a cd. What do I times by 10d to get to this? I need to times by negative 3 to make it negative 30, and I need the e, so it's minus 30de. And then we're done. Once again, if I were to expand this, I would get my original expression. So let's have x squared plus 3x. So this time, there are no common factors for the number. The only number that goes into 1 and 3 is 1, but we don't really count that. But both terms have an x. So that is going to go out the front. So now I say, what do I times by x to get x squared? Well, that's x. X times x gives me x squared. Now, what do I times by x to get positive 3x? Well, that would just be positive 3. And that's my answer. If I expand this, I get this. Alright, sorry for the long video. Thanks for tuning in. Best of luck in your test, but you'll ace it. You're a superstar. Ask me if you need any help. This has been the luckiest maths teacher in the world. Have a great day.